on the science of effective learning. I'm originally from Houston, Texas. This is kind of where I did my studies. I'm currently at UT Southwestern Medical School. In about a month, I will be moving to Arizona and starting my residency in pediatrics. So working as a doctor, taking care of kids. These are just pictures from my white coat ceremony and match day, which is where we find out our job. But long story short, most of my career as a young adult has been as a student. So this is my first full-time job. And so for those of you guys who have many years of experience teaching and learning, this is just my perspective as a student. So would love to hear your perspective at the end of the presentation as well as a teacher. All right, so like I said, as a student in the field of medicine, I've been learning for a very long time, large amounts of information, but it wasn't really until the end of medical school that I learned what some strategies were that were the right way to learn, to study, and to continue to grow as I get older. As part of a course in school, I had to read this book called Make It Stick: The Science of Successful Learning. A great book. That's kind of what the source of my material is for this lecture. And I highly recommend reading it afterwards, writing this book down to look it up later on. There's a lot of great concepts in it, some that were too much for me to cover in this presentation alone, but there's some really nice guides online that give you the quick version of these concepts and teach it as well. What I really liked about this book is that they involve a lot of real life examples in many fields. So it's not just medicine specific, engineering, pilots, athletes, it involves examples from all different fields, which makes it more interesting and applicable to a wide range of people. So we'll jump right into it. To start off with, I kind of organized this presentation by certain myths, things that we think are the best ways to learn, but may not necessarily be true or supported by science. So growing up, a lot of the ways I learned were initially through just rereading the material. We got a textbook, you read it once, a few days later, you read it again, or the night before a quiz or test, you cram all the information into one and you go fast, fast, fast. We think this is the most popular study method, but in fact, it's also the least productive. So we see results immediately with the quiz and we think it's effective, but it doesn't really consolidate it into your long-term memory going forward. So research has shown that the gains of knowledge you get from cramming or rereading these kinds of masked practices are very transient and they melt away quickly. So something called retrieval practice is what's more effective. So it requires you to think of the information on your own, retrieve it from your brain, and then use that. So things like flashcards or a quiz after a lecture. If I were to give this lecture and ask you a few questions about it, that would be my way of getting you to retrieve the practice. Don't worry, I didn't do that, but that's the idea. So sometimes we as instructors and students alike create this we kind of put ourselves in a tough place. So we give assignments with short turnaround times. So you only get a couple of days to do something or one day to do something. And that makes the student automatically cram for the information or the quiz. Then we as students, we don't put our schedule in right. We don't have the disciplined schedule of spreading our learning out. And so we end up cramming the night before the exam. So those are some ways we put ourselves in that situation where the only thing we can do is just quickly reread the material or cram before the quiz. So the idea of retrieval practice and why it helps is that when memory is retrieved and this learning is practiced, the neural pathways of the brain are strengthened. So whenever you learn something new, the cells of the brains or the neurons make a connection or a synapse. And over time, if you don't use that connection, it'll fall away. The brain automatically gets rid of things that it thinks are unnecessary or irrelevant. So when you practice retrieval practice, that strengthens those connections, makes it harder for the brain to take those connections away. Beyond that, we often indulge in, like I said, just kind of repeating the same information, reading the same material over and over. There's a limit of the mind has limits when you're only indulging in learning by doing mechanical repetition. When you just repeat the same thing over and over, the mind can only learn so many facts. Whereas something called elaboration, when you build upon something you already know, allows you to go past those limits. And that's kind of how we grow upon our own intelligence and our own tank of information, of knowledge. So, for example, the principles of heat transfer. I elaborate and learn the principles of heat transfer by remembering that when I put my hands around a warm cup of tea, I feel the heat. That is the principle of conduction. And so now I've added conduction and my understanding of it to this image of me holding a warm cup. I've elaborated on something I already know in real life. And so that allows me to build on my knowledge without it just being a fact of memorization in my brain. So creating these mental models or mental representations of things that you see in real life really help you build on your knowledge and grow. So myth 2, learning is best achieved when we focus on a single topic or activity, when we are single-minded. Often when we learn something, we think that if we focus on it, do nothing else, only that is what will get us to learn the information the best. We think things coming from outside, other information are a distraction. In medical school, we often had multiple exams at the same time. So we would have an anatomy class, that's the body parts of learning about the different body parts. We would have a microbiology class, that's learning the different bugs or bacteria that cause infection. We would have them running side by side. And when a quiz came up, we would often think that the right thing to do was to focus solely on that class and ignore the other class until the next quiz came around for it. But in fact, interleaving or the mixing of problem types, randomizing the exercises helps interleave different skills, and that's better for engaging long-term memory. It helps improve consolidating the memory. It seems confusing, but the idea is that you're used to then learning how to differentiate between the topics. So when things come up, you can be like, oh, this is different from this because of that. And that helps you on your quizzes, because quizzes and tests usually mix all the information together. It doesn't give you, for example, in a geometry test, it won't give you all the volumes of a cone and then all the volumes of a cylinder separately in blocks. The problems will be mixed together, and it's up to you to be able to differentiate between them. And interleaving or mixing of problem types helps you develop those skills to differentiate. So as an example, one of my courses when I was learning about hematology, the way the professors usually teach it is the first lecture is about teaching the basic sciences associated with the system. So for cardiology, it would be about the basic sciences of the heart. And then by the last lecture, they would teach you about the diseases that the heart can go under. This professor for hematology started on day 1 talking about diseases with the basic sciences. So he threw in these terms that we had no understanding of. At the time, it was very confusing. But as things progressed, we had then seen the disease multiple times from the beginning to the end, and we were able to put the pieces of the puzzle together. And in the end, the course was the first course that not a single medical student failed in our class. So that was the first time that had happened. It was pretty common at the time for a couple of people to fail the final exams in courses. And this was the first one that everyone had passed because of the method of teaching. So, and that brings us to our third principle of spaced learning. So to put something into your long-term memory, you need this process of consolidation. And if you notice this graph, the first time we learn something, that red line is a very steep curve. So your memory will fall much quickly when you first review something. Now, let's say 2 days later, I go to the second green line, I review my information. That curve of forgetting is much less steep than my first curve. So whenever you space out your learning, and you repeat what you've been learning over a period of time rather than cramming, then your forgetting curve gets better and better, and you're more likely to retain the information. Now, like I mentioned in the slides, it takes several hours, days, a lot of effort, and it feels like it's not working, but in the end, you retain the information. And finally, so varied practices. What the idea of this is that you try different approaches to one skill, and that helps you develop a more broader ability to do that skill accurately. So, for example, this picture refers to a study that they did where younger kids were asked to throw a beanbag out on target. From one group was asked to do it from 2 feet and 4 feet and practice tossing at those distances. And then the other group was told to only practice at 3 feet. And then the test was that all the groups had to throw from the 3 feet target. So you would think that the group that only practiced the 3-foot target would always get it right and would do better than the other groups. But in fact, the kids that practiced at the 2 and 4 feet, but never practiced the 3-foot, did better on the 3-foot mark. And the reason for this is it required more brain power for them to be judging the distances, how much effort it took them to toss it into the target at different levels. And so it was a more flexible coding of the brain that can be applied broadly. So it allowed them to move that skill easily from the 2-foot mark, the 4-foot mark, to the 3-foot mark. And it's the same idea that when we try different methods of learning, that skill can apply in other situations as well. Overall, all these 3 principles improve consolidation of memory into a good representation in the brain by increasing the routes, the neural connections that I mentioned earlier, by which the knowledge can then be retrieved when you're doing your retrieval practice later on. Furthermore, there were studies in the brain that showed that different kinds of practice engages different parts of the brain, specifically the part that's associated with higher order motor skills. So in the case of the beanbag toss, by them doing the 2 and 4 foot, they were able to do higher order motor skills, and they engaged that part of the brain, whereas the kids doing only the 3-foot toss just kept doing the same action over and over. So they weren't engaging their brain in effortful learning and putting in that effort to apply their skills broadly. All right, so a little bit of basics about how the learning occurs. Like I mentioned, encoding. So when you first see something, a piece of information, your brain converts that sensory, if it's audio or visual, however you're learning the material, into a mental representation in your brain called a memory trace. Now, this is only short-term memory. So to get it really solidified in the brain into long-term memory, you have to undergo consolidation. So you strengthen these mental representations through long-term memory, through the means of spaced practice, spaced repetition, varied practices, and interleaving, those concepts that we discussed before. Reconsolidation is also a retrieval practice where you get the memory from your long-term storage, you strengthen it further, and then you make it modifiable again so that you can add on. So when I was talking about warming your hands around a cup for conduction, I pulled from my long-term memory the cup and how I can feel the warmth when I hold it. And then I added my principle of conduction, the principle of heat transfer to it. And I modified that memory and then put it back into my long-term memory storage. So we associate this material with effective retrieval cues so that we can then recall the knowledge later on. And that's retrieval. Like I said, this mug in my hand will be my cue for remembering the principle of conduction moving forward. Something personal that I noticed recently is I saw my dance teacher of 20 years with my sister, and she asked us to perform a piece from our dance recital or Arengecham from 15 years ago. We didn't think we could remember the steps, but we were able to because we understood the language and remembered what each word meant from 15 years ago. And those served as our cues to then remember the steps that went with the language of the song. So that kind of was how we associated our cues with the steps, brought the memory to the forefront, and it was an effective way of doing retrieval. Seems harder, but 15 years later, we were able to remember it, and it's the same thing with any piece of knowledge. The learning will be easier in the future if you have it associated with cues. Now, this myth also says that mistakes should impede learning. That is, in fact, not true, because when you're struggling to solve a problem, the solution is better learned, and then it's better remembered when you finally receive it, because you've already primed the mind for learning by thinking through all the different ways to solve the problem. Also, you should always say that errors are good for learning when discussing with students, because what happens is when errors are said to be bad for learning, it creates this fear of failure. And then students, when taking their tests, actually do worse because of the anxiety of making a mistake. We also have something called working memory capacity. And what that means is how much memory does your brain hold that can work through the problems on a test. And the problem when you're fearful of making errors is that you waste your limited working memory capacity on checking your performance, making sure you didn't make any errors, being fearful of making errors, and you lose that memory capacity to actually work through the problems that are posed on the test. So it's always good to encourage working through the solution, even if it is like the wrong solution. It's better to try than to not make the attempt. So that way, when they actually go through the test, they're focused on working through the problem rather than wasting their time and energy on fearing that they made an error. Some other ways that are good to think about learning and having that retrieval for later on is reflection. So there's this concept called right to learn. For those of you who like journaling, writing things, that's kind of a similar concept. So whenever I read something, I am forced to create a summary in my brain in my own words. And if I write it out, I'm forced to think about it in my own words, write it down, and that creates a stronger connection with the brain for future retrieval. So you create new connections to the material, you strengthen your existing ones. You're just working through whatever you had learned in your head, and you're writing it out in your own words. And that's what creates new pathways for the brain to hold on to that information. Finally, there's something called undesirable difficulties, should be avoided or made desirable. So what I've mentioned so far are mostly desirable difficulties. So flashcards or quizzes after learning are a desirable difficulty. It's difficult to do in the process. It takes extra effort to learn, but it's desirable because it results in good learning after, once you overcome that small obstacle. Undesirable difficulties are when the obstacle is too great for the student to overcome. So a textbook in a language that you don't speak, you would have to require you to learn an entire new language to even learn the material. That is an undesirable difficulty because it would not be overcome in the period that you have to learn the material, as an example. And myth 4, we are good judges of our own abilities. So this isn't entirely true because, as some of you may know, memory can be distorted or influenced by suggestion. Sometimes when a friend suggests, oh, do you remember when this happened this way? Like tries to remember a conversation from before, you can often be convinced that it happened, even when you don't know for sure. Similarly, the legal system, when they're interrogating witnesses, they try to avoid asking leading questions or suggestion because witnesses often actually have tampered or are easily suggestible with their memories. So when you say, oh, are you sure there wasn't someone standing at the corner? They'll be like, oh yeah, I do think there was someone standing at the corner. So the research has shown that you should always avoid asking witnesses leading questions. Same thing applies to medicine. You don't want to ask your patient a leading question because then you give them false ideas of what their disease process might be, what they came to see you for. So it's always important to make sure that you are aware of the illusion of knowing, the idea that your memory can be changed and influenced by suggestion. Furthermore, something called the curse of knowledge, and the idea that as we become educators or have been educators for years, become experts at our material. And the more you become an expert at something, we have a tendency to underestimate how long it takes another person, starting from the basics, to learn that material, to learn something new, or perform a task that I already mastered. So as an example, as a fourth year, we are required to teach the first year medical students basic physical exam skills. So how to like check out your patient physically. And I was told to teach one how to use an ophthalmoscope. This is the tool that a doctor uses to look into your eye and do an eye exam. And I started explaining it to her, okay, so you put it this way, aim, etc. I tried to simplify it the best I could. And then when she did it, she was using it as a flashlight. And I told her, oh, you have to look through the scope to see the eye. She was looking with her regular eye and just shining the light into the eye. And it didn't occur to me that as a medical student seeing a tool for the first time, they didn't realize that there's actually a lens that they had to look through to even see the eye at a magnified picture. So just remembering to take it down to the very basics is something that we as either progressing educators, students, or becoming experts at something have to remember to do. Then finally, incompetent people tend to lack the skills to improve because they can't tell between incompetence and competence. So what that means is people, when they're not doing well at something, they're often quite bad at actually judging that they're doing poorly at something. And there are two reasons for this. One, we are afraid to give negative feedback. So sometimes we as teachers or even friends and colleagues will avoid giving negative feedback because we don't want to make someone feel bad. And what's important is that you change that negative feedback into constructive feedback. And so you give them feedback to improve their skills and abilities while still praising their effort and their hard work. Additionally, the people who are incompetent usually need to learn the skills on how to judge their own performance objectively. So by a rubric, by a scale. If you're a teacher grading someone on a rubric, it's always a good idea to show them the rubric so they know what their skills are being tested on and how they can improve. And this brings us to one of our last myths. So students fall into different categories of learners that are distinguishable by learning styles, and they learn better when the instruction is in that style. So what are learning styles? That's when I come to you and I say, oh, I'm an audio learner, an auditory learner. I learn best when I listen to things. Or someone says, I'm a visual learner. I learn best when I see something and can process it. So this is something that's common here in school. I often thought I told everyone I was a visual learner until I read this book. And there's actually little evidence to support this theory that people are associated with learning styles and that they learn best when the information is given to them that way. So there's actually very little evidence for that currently, and it's a very hard thing to test accurately. So for now, we approach it with the idea that it's a preference. We prefer to learn in this way, but we don't necessarily learn better in that method. So what's more important is that the way you're teaching matches the nature of the subject. If you're teaching geometry or geography, you need a visual image. Geometry is best learned when you can see something, like see the pictures of the objects and figure out how the formula for the volume for the surface area applies to that. Geography is best learned when you're looking at a map. You don't want to be learning geography when you can't actually see the picture of the countries and the capitals associated with it. Similarly, verbal is probably the best method for poetry. So you can hear the tone, the speed, the rhythm for poetry. So the differences that do matter. Language fluency. So for those of you who need to learn things in Tamil as your first native language, that would be where the differences matter. You'll learn the material best when it's in the language you're most fluent in. Or reading ability, dyslexia. So dyslexia is pretty common, especially among kids. Kids affects 15% of the population, at least as measured by the United States. What it means is that during pregnancy, there was a slightly abnormal neural development with the neuron connections, and it interferes with the child's reading ability. So the brain's ability to link letters to sounds is disrupted. So you want to diagnose these kinds of things early, before the third grade, ideally, while the brain is still more plastic, more malleable, so you can reroute those neural connections So when you're missing the link to the letters and sounds, you want to find a way to reroute them. And there are different ways to do this that are encouraged, such as, practice with reading, practice with phonemes, which are the sounds that letters make. Undiagnosed, it has been shown in research to lead to failures in school, often resulting in low self-esteem, and eventually causing things such as criminality. So they tend to focus on bullying, etc., and that leads to later problems in their adult life. So more criminal behavior. So it's very important that you diagnose this early, ideally before the 3rd grade, so you can work with them. Now, this is where the difference matters, right? But there are ways to overcome it if you diagnose it early, etc. For the rest of us, we just need to learn material in all the ways we can. Audio, visual, it doesn't matter. So the more ways you can learn something, the better, in fact. Now, the ability to raise our intelligence. Is it possible? So as a kid, I think we're mostly aware that yes, it is possible. Starting from things like nutrition, breastfeeding has been shown to raise intelligence. Giving dietary supplements of fatty acids to pregnant women, breastfeeding women, and infants has actually been shown to raise IQ by 3.5 to 6.5 points, which is pretty significant. So fatty acids are the building blocks for nerve cell development that the body often can't produce alone. And so this supports like new connections with the brain, and that therefore helps raise your IQ. Socioeconomic status. So what that means is houses of poor income where both parents work or are uneducated and therefore can't educate their child by themselves have been shown to affect intelligence from the start. Ways to overcome this: increase stimulation and nurturing of the child, reading to them. One method that we can try is enrolling poor children in early education. So this is prior to preschool. You get them in an environment where their learning is enriched, they're undergoing structured learning, reading, good development skills, and that has been shown to raise the IQ by more than 4 points in a center. Sorry, more than 4 points if it's done in the home, or more than 7 points if it's done in the center. So because in the home, it's not easy to observe that this stimulation is happening consistently, which is why the point difference is a little smaller. Whereas in a center, you can have people to observe and to supervise and to encourage a consistent process of stimulation. Additionally, when mothers of low-income homes are given this training, it is also shown to help with the IQ, with intelligence. Now, at the end, when we are adults like we are today, how can we grow? Sometimes you feel like you're at a plateau, like you can't learn anymore. You can't get any, like, yes, you can learn more information, but can you get smarter is the question. So the idea is a lot of it comes from attitude when you embrace that growth mindset. So there was a study done with a junior high school in New York where they were given, half the students were given an explanation on effortful learning and how if you take effort, it like results in growth. The other students were not. And then when they conducted tests for these two groups, the groups that got the explanation on how to learn effortfully did much better than the other students. The idea that the brain forms new connections and over time can make you smarter. Intelligence is within your own control. Telling people that gives them the mindset to persist where others might fail. So they're more likely to work through the problem and keep going and keep trying than other people who might fail because they think they're at the limits of their intelligence. So on that note, it's always good to use learning goals instead of performance goals. So instead of praising a student for being smart, it's always better to praise them for being, for working hard, for being effortful. So, oh, you work so hard on this, good job, rather than saying, oh, you're so smart. When you praise their natural ability, then they think that that's the most they can do. So when they're given harder challenges, they won't try to try new things and do better because they think that's the limits of their intelligence. So it's been shown that the students who are praised for working hard take the harder challenges on, first of all, and that they continue to work towards those challenges because they feel that they can control how hard they work, but they can't control their natural intelligence. So that's the embracing the growth mindset. Practicing like an expert, deliberate practice. So these are the experts in piano, dance, a chess player. People are often praised that, oh, there must be some natural talent under that. But that's usually not the case. It usually takes an average of thousands of hours of deliberate practice where they're hitting goals and then they're striving to go beyond those goals. And so that builds new knowledge, new mental models, and makes them grow upon what they've already known. That being said, once you're an expert at something, it's very rare that you can become a true expert at anything else. But when you practice your knowledge in that same idea, where you set a goal, you achieve it, and then you don't stop there, you create another goal to work towards, and you keep practicing, putting in the hours of effective learning. That's the practicing like an expert that will get you to expert performance that you see with those prodigy chess players, etc. And finally, constructing memory cues. So this was kind of the idea of when I said the brain has limits until you elaborate on your existing knowledge. So a memory cue, like a mnemonic device, such as Roy G. Biv. We use that to remember the colors of the rainbow here. So Roy is red, orange, yellow, G is green, and Biv is blue, indigo, violet. And that's how I remember the color spectrum. And that's what they teach most kids growing up. So that's something that we remember from kindergarten up until the time we leave this world. So, but there's other memory cues, something called a memory palace. So that's where you organize and hold larger volumes of material in your mind using images. So there was this study done in England where these students would go to different coffee shops every day to learn a particular piece of material. They went to one coffee shop and would learn about one psychologist. Then they went to another coffee shop and would learn about a different psychologist. In these coffee shops where they discussed it as a class, they would pick out people in the coffee shop and use it to remember things about the psychologist they were learning about. So when it came to the test, this student, all they had to do when they were answering the essay question, all they had to do was think about that coffee shop. Who did I see in that coffee shop? And then they associated the image of the people they saw, the things they experienced, with the information that they could have learned from a textbook. And it proved much more effective for learning long-term. So as a more real life example of a memory cue, if you're talking to a friend about a trip and they said, oh, remember that conversation we had, and you don't remember it, often the friend will be like, remember we were driving to this place, we had turned the corner, and then they allow you to create that memory in your head, and it makes it easier for you to remember that conversation you had at that turn in the road. So once you picture the place, sometimes you can associate your memory cues with the knowledge, and this applies to regular information as well. There's a tool that we use in medicine, I'll show a little bit about it later, called Sketchy, and that uses this idea of the memory palace, and I'll explain some more when we get to that slide. So overall, effort learning changes the brain. You get these new connections and capability, and it's really yours to shape. If you keep up with self-discipline and persistence, that's how we grow past our adult life. When we think we've reached the limits, you really haven't. Okay, so all things being said, if there's one thing we want to focus on now, if you don't remember any part of this lecture and or didn't really comprehend it on the first go, we'll send out the slides, but this is something to keep in mind. As an instructor, it's always good to explain how the learning works, kind of with the students who did better when they learned about effortful learning, when they understood the science behind it. It's the same thing with everything. When you tell them how learning works, they will do better. Teach the student how to study. So avoid rereading, cramming, mass practices. You want to practice quizzing, reflection, spaced repetition, and interleaving different topics into the teaching. And use different methods of study like reflection or elaboration. create these opportunities for learning for your students. So those frequent low stakes quizzes after a lecture that maybe was too much to sit through, give them a quick multiple choice or freehand answer quizzing, and then that'll help them think about the topic, consolidate the information, and save it for later. And just overall, explain to them why you're using the strategies you're using, and you'll find that they are more effective learners because then they can adopt the practices themselves moving forward, as I found when I took this class. All right, so this brings me to a couple of tools that we used in medicine that helped us progress our knowledge, that used these strategies such as spaced repetition, memory palaces, creating those images. So I'm actually going to, so real quickly, Anki is a flashcard app. So what it does, it basically spaces out your learning so that you look at flashcards multiple times throughout days, months, years, even if you wanted to go that far. It was initially created for learning new languages, and then has more recently in the United States become a very popular method for learning for medicine and law school exams. Sketchy is that memory palace. So when we have a large amount of information to learn in medical school, such as microbiology, all the different bacterias and viruses that can cause an infection, they split it up by these videos where they tell you a story in the video, and then you can associate each piece of the video with a part of the information that you have to memorize. So for one bug, it'll teach you the symptoms, what causes the disease, the other kinds of complications from the disease, how you treat the disease, and how you can identify the disease. So when you grow a bacteria and you stain it a certain color, how do you identify if it's a red color, then that's this type of bacteria. If it's a purple color, then it's this type of bacteria. So it's different things like that that help us associate the memory and link it through these videos. And it was very effective. All the studies have shown that people do much better when they use these tools for their medical exams. So I'm going to actually kind of pull up a couple of these to just show. But before I do, these are, for one more time, these were kind of the resources. And the one at the top would be the Make It Stick book. So if anyone wanted to note that down, that would be the book that I used for the majority of this information. Okay. So I'm just going to play a couple of minutes of one of these videos from Sketchy. This is a paid subscription to a medical, it's only medicine currently. Hopefully in the future they create more. This is specific to microbiology. So it's a specific type of bacteria called Staph aureus. I'm just going to play a couple of minutes just to get an idea for what it looks like. But as you can see, there's all kinds of concepts that they teach through Sketchy.
And I'll be guiding you through this chapter on staph and strep. In this video, we'll be bold and dive right into perhaps one of the most important bacteria you'll learn for microbiology, Staph aureus. She's a beast. If you make it through this video, I promise it'll only get easier. The name Staphylococcus aureus tells us a decent amount right up front. Staph and coccus come from the Greek meaning grape and granule, respectively. And this is because under the microscope, staphylococci look like a bundle of grapes. Now, aureus is Latin, and it means golden. And this is because when it grows on blood agar, its colonies have a yellow or golden appearance to them. So we took this idea of it being a golden staphylococcus, or golden staph, and we've called this scene the golden staff of Moses. I hope you enjoy it. Now, I'll start by drawing this desert background. You'll notice I've gotten really fast at drawing. Yeah, you know, I guess it's just practice, what can I say? Anyway, here's Moses. He's carrying a very impressive golden staff, the golden staff of Staph aureus. Notice his robes are violet. We did this because Staph aureus is gram-positive. And gram-positives take up crystal violet stain in their thick cell wall and hold on to it even after the rinse and the addition of red safranin, so they appear violet under the microscope. We'll tend to use a lot of violets in the gram-positive videos, and likewise we'll use reds in the gram-negative videos. Let's keep talking about how exactly we can identify Staph aureus in the lab. So far we've gone over that they're gram-positive cocci, but so are strep. So how are you going to tell them apart besides their shape? The first test you'll use is a catalase test. Catalase converts hydrogen peroxide to water, and is present in all staphylococci, but not strep. Since staph is catalase positive, we'll add this cat, standing for catalase. You'll notice you won't see a cat in the strep videos or any catalase negative videos. We've placed them right here, front and center, and we've even made them look cool and Egyptian looking so that you don't forget about them.
So as you can see, like they kind of use images, so they associate the cat with catalase in terms of a stain, and the purple is what you would see with the gram stain, and that's how you identify this bug. The Staph aureus is this staph right here, and the A is to remember, and the fact that it's gold is to remember that aureus is also a word for gold, like aurea. Now, as you go through, I'll just kind of skip through, as you can see, they keep going, adding different pieces of information to talk about the disease. And by the time you get to the very end, it is quite a full image. So it can be a lot of information to remember in one go. But the memory palaces help, because when I go back in my test, I just think of this image. And once I think of this image, I remember, oh, there was a cat here. So this bug was cat positive, catalase positive. And so that's how I answer my questions on the test, when you have to remember a lot of different facts. So it's something I watched these videos once when I was in my first year, and I still remember quite a few of them 4 years later. And hopefully I'll remember quite a few of them 10 years from now. But that brings us to another way to consolidate this information, which is Anki. So I'm just going to expand this so you can see. And the way Anki works is you have all these different decks. So you can do, if you notice, I have a medical Spanish deck here. I have different types of categories in medicine. And the way it works, so for example, we just watched a little bit of the video from Staph aureus. So I go to sketchy micro, bacteria, gram-positive cocci, and Staph aureus. And I can click on it. And now I can start learning if I wanted to. So if I click study now, it first asks me what characterizes Staph aureus, and it forces me to think of 4 things on my own that can characterize it. It doesn't give me the information, so I have to work on retrieval practice to bring that information to the front. I click show answer when I'm ready, and then it gives me the answer. It gives me the answer as well as images associated with it to help me remember, to pull up that video from my memory and reinforce that information. If I wanted more information, I can click on more about this topic, and then it actually pulls things from textbooks. So whoever created this deck, which is very famous online, these decks can be found on the web. You just search for Anki deck and the name of what you're looking for, and you can find them very easily. And I'll show you how you can find them as well. But whoever created this deck pulled information from one of our main textbooks and just copied it in here. So if you feel the need to read more information and you want another reading of something, you can in fact do that through these flashcards. Now, remember when I talked about spaced repetition, if you look at the bottom, there's ways of encoding whether you want to see whether this card was hard, good, easy, or you got it completely wrong and you need to see it multiple times. And so the time on here, less than 3 minutes, less than 9 minutes, less than 15 minutes, and then 3 days, is how Anki's algorithm spaces the learning based on how well you learn it. So if you know it well, it'll give it to you in 3 days. So it increases the spacing. Still works on your long-term memory, but you don't need to see it as frequently. So it encodes an algorithm of spaced repetition. So if I say again, as I go through my decks, I'll see it again in less than 3 minutes, like it did here. So, okay. So that's a little bit about that one. Another thing that's cool about this is that you can add something called add-ons. So I have an Amboss add-on, which what that does, it's a medical library. So see how some of these words have blue underlines to them? When I hover over it, I get more information. I can click here. You can't see it because of the way my screen is, but Here you go. So if you go here and you hover over this way, it loads up your library and it can give you more information on the topic. So you can see the cytoskeleton, catalase, and it gives you more information to read. So that's another way outside of textbooks from reading information when it has these connections. So if I need to learn more about beta hemolytics, I could then go here and scroll through more about that. So that's how that works. And let me show you how you can find some decks as well. So this is the Anki web. So you can use Anki on your phone. You can use it on your computer through the app, which is what I showed first, and you can use it on the internet, just on the web like this. Same idea. I prefer the computer and the phone. Phone is easy when you're on the go and moving, but the app is also nice on the computer. So whenever you want to look for decks, you can go to ankiweb.net/decks, and then you scroll all the way to the bottom once it loads. And you can get shared decks right here at the bottom. So remember, Anki was originally created to learn languages, but there's also all kinds of topics: anatomy, biology, chemistry, geography, history, law. If I were to type in something like Tamil, they have quite a few Tamil ones. And if you notice, they also have, they can show you which ones are audio. So there are some audio ones here. So you'll notice some of the cards will have audio function as well. Because like I mentioned, this was originally created to learn languages from, which is why the audio functions are there. So you can actually listen to things. How this helps me in medicine is I go to, let's see if I can find it, internal medicine. I go to murmurs. So when I was learning how to do heart murmurs, all right. So I believe that brings me to the end of my presentation.